Chapter 1.3 looks at problem solving. What we know is that the heart of mathematics is problem solving, right? We have thinking and how it helps us think better and um, apply it to our world, which ultimately would lead into problem solving. So we start our course with this idea, but keep in mind problem solving will exist for the rest of your life in this textbook for sure. But as you go on, we're always looking, right? um, to problem solve. It's probably a primary reason for studying mathematics. It's not just about procedures, but also about developing conceptual understanding of why and how things work. And so that's what we're going to engage in problem solving and hopefully start to think about what are the things that we are learning when we problem solve? How does it create productive ways for us to think, right? And develop strategies that we can apply not just in this course but in your everyday life, in your future classroom, with your family. So there are things that we're going to consider as we go through it, and hopefully this introduction will help us start to think about problem solving. So it begins with this wonder play grow, which we would spend some time in class having students play with. And of course, since we're not together in person, I can't watch you see what's going on here, but you have a chance to try to draw curves to connect, right? A, B, and C, but the curves cannot cross. And so you try it, go for it, do it, pause and do it. Okay, you've paused, you're back. Now in our textbook, oh, I got to get to chapter 1.2. In our textbook, right, when you get to chapter 1.3, you will see a little video that I want you to take your time to do here that kind of explains how to solve the problem. And one possible, and again, this is one possible solution, is to somehow come up with an easier way. Think about it from a different context. So you would play that video. It's a quick one, only 10 seconds. But again, play it multiple times to see. So it started with just starting from the most basic way, right? If it was straight up and down, that's how you would solve it. And then they move the pieces to try to make it. So consider that as, again, a productive problem solving. And it's not a trick. It's just being willing to try something and go for it as you're trying to solve a problem, not afraid of being wrong. There's nothing wrong with trying something, and we'll look at specific things. So when we have these conversations around problem solving, right, we want you to pause to think about problems versus exercise. What's a problem and an exercise, right? So we know a problem is something that you don't know how to solve. You don't know how to, what the answer is. It's not obvious. And so you have to think deeply about what approach do I take to solve it? What are the things I can try? So part of problem solving is understanding what is being asked, obviously, and then we can get to a solution. This is, again, I think true in any kind of case, right? Even as we wander around the world, we come to a situation. What is the problem? What are we trying to solve? And what are the possible solutions? And sometimes there's more than one. And that's different than an exercise, which is often just something where you're practicing. So just keep that in mind when we have that conversation in this class. We'll be talking about problems and exercises, even though we're going to see the word problem. We get used to thinking about it as an exercise. Exercises are more around things that we already know how to do and we're practicing. So what number plus 4 equals 7? Again, in general, this is an exercise, but it could depend upon the learner's level. If it's a kindergartner, they may have to think a lot and not know the answer right away. But again, so problems and exercises, again, vary from student to student. Let's take a look at a simple, and let me not say the word simple. Simple doesn't always mean easy, just means an example that hopefully demonstrates what we're talking about, right? So to make it obvious, doesn't mean it's an easy thing to solve. So here's a situation that provides us a problem, because I don't have an answer right away, even though we see a solution, right? So we want to add up the numbers using only the digits 1 through 7, so that the middle horizontal and the diagonals all have the same sum. So we have to first understand the problem. What's the process? How would we solve that? Require some thinking. What would we do? In a case like this, which we learn later, I would just kind of try things, not be afraid. Let's get it wrong. Let's get messy a little bit. This is ultimately a solution. You may find a different one, but ultimately, you start adding numbers, but you will see 1 plus 4 plus 7, 3 plus 4 plus 5, and 6 plus 4 plus 2 would all work. Again, looking for common sums across the middle, the diagonal, and here. But you could now see, again, it's not really about the solution here, but really identifying what's a problem, what's an exercise, how would we solve it if it's a problem. Maybe if someone's done this a million times, then it's an exercise. If it's your first time or first few times, it's a problem. And problems we got to figure out. We got to think, what's a process? How do we solve it? So we'll talk more about that moving forward.